Okay, let's take a look at the PCB board. This comes from the JLC. Thanks for the JLC support this project. So let's take a look at the new one. This new one looks much clean, and compare with the old one looks ugly. Yeah, I put the cable directly on the board. I soldered the cable directly to the ESP32 pin, so it's look not very clean. This cable is for the little display, so I decided to probably redesign the board a little bit. So there's some more change for the sensor, the level sensor. I put in the center of the board, so it's could more close to the board. This one for the cable for the power supply of the servo motor, because this one is not very reasonable, because if you plug in this one, you cannot put the cover. Also for the antenna of the Wi-Fi, if you are looking at the new one, you will see the cable is more close to the board. So even you put the cable, you still could put the cover on top of it. Yeah. So this will be more reasonable. Also for the antenna is shorter. Actually, I upgraded the ESP32 for a new one. Yeah. So let's put this together, so you can take a look at the sides, pretty much the same, but it looks much clean. Also, I put the logo, put more label on the board, so make it looks nicer. I will show you more detail about the design for this board, and upload the changes, upload the design to the GitHub. So you guys could take a look, and you could download that and modify if you need to do that. Yeah, let's start about the more detail about the design. Okay, let's take a look at the PCB design and how to make the order for the PCB board. So I use a free software, online version. So the name is EasyEDA. So EasyEDA. Okay, let's open this one. This software is about the circuit design. So we pick up the online version, and it's free. So it's an online pro version. So I already log in and put everything to this account. So here is the file. Let's open all the file. So all file for the EN01 is here. Here is the coder. Let me take a look at the coder. Yeah. So let's take a look at the diagram. This one about how to get the real-time direction or position. This is ESP32 and some interface. These two are the driver for the motor. Yeah, that's for the converter. Yeah. This one about the series port, about the programming. So when you program the device, that port is for this purpose. Right now I add this one. This one is for the display. So let's take a look at the PCB board. Here is the port for the display. So let me hide the wire. Okay, so you can see this is for the display. I just connect this one to the ESP32 board to the pin. So we don't need to use the wire, connect the ESP32 directly. This will look much better. I did some change for the layout and the logo. Yeah. Let's take a look at 3D preview. It's cool, right? It's much cleaner. Okay, I use the black because black looks more nice. So here is the 3D preview. For the back side, I set aside 6 pin over here. This for the I could put another small PCB board for the charger, because right now every time we have to take off the battery and start charge. But later, I think we could have a charge port over here. So this one is for set aside for the voice control. We could do the voice control, or we could use this serial port to communicate with the external application. Like if we have the Raspberry Pi, we have another micro processor. We could use this one connected to the micro processor, like a Raspberry Pi. Yeah. Okay, this is a main design. So next, let's take a look at how to make an order, place an order. So we just go over here. Let's check the DRC. Check DRC may take some time. Yeah. So let's confirm. So, okay, it's already loaded. Most of the parameters already parsed and get correct value based on your PCB design file. But sometimes you need to change the color. This one is confirm for the production file. Is depend on your requirement. You could, but this one I think need to pay separately. Okay. Every parameter looks good. So basically you only need to change a color. That is all you need. Let's take a look at the PCB assembly. Let's open this one. So you pick up some parameter again. Like if you only assemble the top side. I prefer has GLC do the assembly. You could assemble by yourself, but it will take much more time. Let's click next. So, okay, it's pretty simple, right? This is a PCB board. I have not imported the BOM. I will show you how to do that. So this one, we need to process the BOM. I don't put the label sensor. I don't import that, so but I could manually import that. Okay. Here is a BOM, the list of the material. These two use the same one, so I just pick up both of them. This one seems out of stock, so you could pick up a different one or a similar one. You don't need to have to use the same, exactly the same one. So I just use this one to do the search. Because this part is pretty common, so let's pick up another one. The price is pretty much the same, yeah. Yeah, because some of the resistor or capacitor not available or not in stock, so we could pick up a replacement. Okay. Okay, that's next. Now we can take a look at the result. You need to make sure your circuit diagram is very precise, otherwise it cannot get the correct parts to the correct location. Yeah, so here is the result. You need to double check this one, make sure every part put to the right place. You can say, okay, this one is not right. Seems it's in the wrong direction, so you need to rotate this one. Just press space key. You could rotate this, just clockwise to rotate this. So double check everything. Make sure everything looks good. Okay, let's do the next one. So next we could place the order. We could add it to the shopping cart. Here is a summary for the price. So you can purchase the whole board I already created from the link in this video, but you could also do the same thing like I did, just purchase from the JLC PCB directly. So here is the final result. Let's double check both sides. Let's say check out. Okay, I think that pretty much was how to do the PCB design and how to make a PCB order. Wait for few days. It will get the PCB, JLC will send the PCB board to you. Let's take a look at the difference between the old one and the new one. So let's put it together. The white one is the old version, so you can see the wire everywhere looks ugly. So you can take a look. We have a lot of wire over here. So this is just for the screen, for the display. You can see the antenna also is longer than this one. So the new one looks more pretty. Yeah, if you look at the layout, this is the label sensor. The label sensor is over the air, so you can see there's some distance. But the new one, we just put the stick the sensor on the top of the board, so it's more reasonable. Yeah. So you can see this port, this cable, I moved to the back of the board. But the old one, there are two sides. There still have some cable. So let's take a look at the performance of the new one. Let's turn it on. Yeah, now this emoji is the device is turning on. Yeah, I wish I could have this automatically stand up, but right now I still need support it. Yeah, I need help it to stand up. No, right now it's still do the self-check. Okay. So it's on. You can, from the emoji, you can say it's on. Yeah. Now, let's control this one. The battery, I use some new battery. You don't need to use a homemade one. Okay, so you can see the emoji. If you move forward, it will display like this, or backward. So I have the emoji, I have the interaction. So I don't need to display the whole emoji. So once it's the action change, turn left, turn right, it will change the emoji. Oh, right now. Okay, let's try again. So it's turn left. When you turn left, you will see the eyeball is on the left. Turn right, the eyeball is in the right. Yeah, it immediately changes the emoji if you have the different movement, which is very cool.